Hey everyone, welcome back to the channel. My name is Dennis and welcome back to 1 Year 365. And today we will discuss about something. It's a little bit about follow up about things that I I made a few days ago. I made an episode about why I think that there is no other life form out there in the space. It's because basically it's as simple as if something the location, if it does happen, the location is far away from earth, right? The same thing you can also think about, the time as well. If it does happen, it will be far from now, either far to the back or far to the future, but not like at this point in time. I don't think two life form actually coincides to exist like at this exact moment. And yeah, that is the basically the point of that video. I don't know if you have watched that or not. I don't know if you got what I said or not, but yeah, maybe a lot of people disagree with that. I have no idea because when I record this video, I haven't actually seen that one. That one hasn't been released just yet. But when this video is out, obviously that one is already out a few days ago. So yeah, basically what I said is that space and time. Do not forget about time as well. There is billions of years of span, lifespan, and what makes you sure that other life form like human actually there's a catch as well. It's not just as simple as microorganism. It's literally like other intelligent being, which I doubt that it's actually existing like right now. So yeah, it's either they already existed back then and then they extinct. Maybe there's doomsday for them. I have no idea, or maybe they're still not developed just yet. Maybe they're still, I don't know. I don't know, like maybe they are still in the state of Cambrian explosion. Like maybe they are still that weird looking creature. They haven't evolved just yet, or maybe they are still dinosaurs. They haven't evolved into I don't know, like maybe primates or something that soon later on there's human, or any other things. I doubt that they are maybe maybe they are still in that phase that they are not actually developed just yet. They need few million years probably until they fully develop. But yeah, yeah, basically there's that. So today's discussion will actually see about potential habitable exoplanets because well, if you believe that there might be other life form out there, what about we talk or discuss or see from the list of the planets that are habitable by human at least. Maybe there are some condition or planets that are very extreme, but somehow there's actually a life form there. We're gonna exclude that, but we're just gonna talk about life form that is like Earth basically, like human. So yeah, which is this one, habitable exoplanets. We'll see from the list. You know like uh like what makes a planet habitable, what what's the criteria, how many we have discovered so far, we'll see if there is any any saying from researchers probably if it is actually possible, or if it's or if that they already observe using telescope and they don't actually see signs of life, like maybe it's simple as when on earth you build something, right? If you look at that with telescope from outer world, I feel like you will see lots of movement, right? Like there's nothing there, but now there is something. It means that something must have changed, and who changed? Well, human. So yeah, um, maybe we'll get some answer if they already did that or not. From far away, if that is even possible or not. So yeah, but anyway, let's just start. This is a list of potentially habitable exoplanets. Yes, it's mostly based on estimates of habitability by the HEC or Habitable Exoplanets Catalog. Yeah, and data from the NASA Exoplanet Archive. The hack, the HEC is maintained by the Planetary Habitability Laboratory at the University of Puerto Rico at Arecibo. Okay, so it's in Puerto Rico. Oh well, I don't know. Maybe it's the name is Puerto Rico, but maybe it is not in Puerto Rico. Who knows, right? I mean, well, you guys probably know. I don't, so let me know, I guess. There's also a speculative list being developed of super habitable planets. Oh, super habitable planets. That is very interesting. Surface is thought to require orbiting at the right distance from the host star for liquid surface water to be present. Yeah, I guess it makes sense because you need heat and pressure as well. In addition to various geophysical and geodynamical aspects, atmospheric density, radiation type and intensity, and the host star's plasma environment. Okay, so alright. List. This is the list of exoplanets. Yes, circumstellar habitable zone that are under 10 Earth masses and smaller than 2.5 Earth radius. Okay, okay. So that is basically the requirement or the criteria, right? It is less than 10 times of Earth and smaller than 2.5 times of Earth radius. Yeah, and thus have a chance of being rocky. Oh, that's why, because if it's a little bit too weight or too heavy, then it probably will be not a rock, maybe it will be I don't know, like a solid thing. Like if you talk about rock, it has holes, right? You will perceive that it has holes, but maybe this, if it's too compact, it won't have such things. Or if the gravity, maybe it affects the gravity actually, because gravity is heavily affected by mass. So yeah, um, maybe the gravity will not sustain as well. And then as for radius, I guess again, like if the radius is too big but the mass is too low, it might actually collapse and turn into gas planet. Maybe, I have no idea. So yeah, you got the point, right? Like if the volume is a little bit too big, but there is not any mass, then it's hollow, right? It's hollow, and for such big thing, what's gonna happen? Well, it's most likely gonna collapse and I don't know, disintegrate into gases, and I don't know, it turns into gas planets perhaps. Or maybe if it's too compact and there's like the mass is too high, then it's too pressurizing, right? The gravity is too high. There might not be any atmosphere as well, because since the gravity is high, then the air got condensed down, at the very down bottom layer, which means that there might not be any atmosphere. So yeah. What else here? Yeah, I think there's that. Let's see here. Object star, star type, mass, radius, density, flux, uh, temperature, I believe, because K as in Kelvin. Period, days. Oh, this is just revolution around its star, I guess. Revolution around its star. Distance, light years. Okay. Reference or notes. Yeah, like distance is light years, right? It means that it's too far away. Like again, what makes you think that it also happens right now? Why not it happens like light years away, not years away, but more like light years time ago, you know what I mean? So yeah. Anyway, object first, Earth. Obviously, this is our Earth. Sun, Sol. I think it might be solar or Sol. Star type G2V. I have no idea what that means. Mass is 1 of Earth, obviously. Radius is 1, obviously, because we're referencing ourselves here. Density, okay, 5.5. Flux 1. Temperature 255. That is so 200 or 0 degrees Celsius is actually 273, which means that 73 minus 55, that is 20, no, that is, wait, what is it, 73, 50, 18, I think. Yeah, 18. Minus 18 degrees Celsius. Oh, that is interesting. I thought we have like warmer thing, but apparently not. But all right. Period days will be 365.25. That is not necessarily true. I believe it's 24 something something, but yeah, I guess for the sake of our simplicity, we actually adapt that it is 0.25, with exception that every 100 years we don't add extra day. So yeah, distance will be 0 light years because obviously it's here. Reference or notes reported for reference. Only planet known to support life. Okay, there you go. Only planet known to support life. Despite of how many things we found, this is the only one that support life, which is a little bit terrifying as well, because down the list, as you can see, there is so many of them, but we only have one, which is Earth. And yeah, again, there is so many candidates over here, but none of these might be habitable, which means that um, I mean, by not habitable, I mean it's actually habitable because obviously it's over here, but it's not yet proven that something actually lives there. Well, I mean, I don't know about that as well, though. Maybe they already proved that there is no one there. I have no idea, but yeah. Anyway, so far we only know that Earth is the only life form, right? So yeah. Tea Garden Star B. Okay, Tea Garden Star. I have no idea where that is. M7V. Just the same. Radius is estimated. Okay, estimated. So they're not sure yet. 12.5 light years away. That is a long distance. What else here? Confirmed to be rocky. What is that? Trappist 1D. Okay. Trappist 1. I guess D is for the fourth planet, probably. I don't know. M8V. I don't know what that means again. 0.39, 0.78. Well, that is a bit unfortunate because obviously 0.39, that is less, that is smaller, and also 0.78, that is smaller than Earth. Yeah, density, flux, the what about uh gravity? It doesn't mention about gravity, I guess, over here. Just fine. Affected by solar flare, possibly affected by high radiation, which is in Proxima Centauri. P Proxima Centauri. I think I know this one. Proxima Centauri, isn't it like one of the biggest sun? Yeah, biggest sun, I think. Yeah, okay, here we go. You can kind of see the size is more than Earth, right? Yeah, affected by solar flare, possibly affected by high radiation, which we might not want, but we might also want. I have no idea. Sometimes radiation. I mean, it. I don't know. I don't know if the sun to Earth is that radiation or by convection. I don't think it's convection because convection, signifies that there's actually fluid, right? There is like a fluid, but obviously there is no fluid because the space is empty, which means it is actually radiation. So in that case, I don't know what this radiation means. Is it like heat radiation, or as in like a radiation, like a what is it called again? The radiation, radioactivity radiation, I guess. So yeah, but by the looks of things, physically, I think this might be about heat. So, okay, which means there is heat. There is something already, which means the planet's probably warm, at least warm, and it can have atmosphere potentially. Next, we have confirmed to be rocky. Okay. Oh, Trappist 1E. So it's the neighboring. Okay. What about Trappist D? Also rocky. Okay, so it's rocky planets. Confirmed to be rocky again. Trappist 1F. Okay. Well, now I'm actually curious where this is. 41 light years away. I don't know. Is that still in Milky Way? I think it is, right? Yeah. Confirmed to be rocky. What is this? 1G. Okay. Is there 1H or something, or we just keep going? I don't know. Not confirmed. Okay, not confirmed. I guess. Oh, this is a little bit too heavy. 5 times of the mass. Right? Yeah. Okay, 5 times mass, but somehow it retains what is it? 1.6 radius, so it's a little bit solid, more solid, I guess. But I don't know. Yeah, okay. Density is not specified, but which is fine. Not confirmed. Okay. What else here that is interesting? Highly eccentric. I don't know what that means. TOI 2257P. Okay. Highly eccentric. I don't know what that means actually, honestly. Maybe it is, not suitable or something, not confirmed. Okay, there's this one. Gliese, which is 6.4. That is even heavier. Not confirmed again. We have 7.09 and confirmed to be Rocky. Okay. LHS. Oh, this is 6 times, but it is 1.6. And then there's also density. Okay, that is actually heavier than Earth. 7. Earth is, I believe it was 5.5, but this one is 7.8. So it's rocky, but as in solid rocky. Okay. Highly eccentric. Don't know what that means. Only in HZ if very optimistic models used. I don't know what that means as well. Unconfirmed candidate. Okay, so alright, interesting. Previous candidates. Oh, there's previous candidates, which is more interesting as well because obviously previous candidates really means that maybe it was candidate, but then they did further research that apparently there's something that something wrong, right? And it is not actually habitable or things. Maybe there's extreme condition that they overlooked, and yeah. Some exoplanet candidates detected by radial velocity that were originally thought to be potentially habitable. Radial velocity. Radial velocity. Is that like. Oh. Wait, what? Is it like rotation basically? What is radial velocity? Oh, I think radial velocity means that it's probably. I don't know, maybe. I have no idea what that means. Were later found to most likely be artifacts of stellar activity. Okay. Radial velocity. I have no idea. Maybe maybe it has something to do with the speed of the planet, I suppose. This include Gliese 58, okay, Gliese, Captain, and Gliese, okay. Was initially estimated to be potentially habitable, but updated models for the boundaries of the habitable zone placed the planet interior to the HZ, okay, and it is now considered non-habitable. Oh, HZ is habitable zone. So basically, um, they later found out that it is actually a little bit too close to the sun, so yeah, it's not habitable. Maybe it can get too hot, right, during some point of time. Next we have Kepler has gone through a similar process, though initially estimated to be potentially habitable. It was quickly realized that the planet is more likely to be similar to Venus. Ah, okay, well, Venus is probably like the worst thing for habitable planets because obviously it's too hot. I think it's too pressurizing as well. It's too hot as well. The hottest planet. There is greenhouse effect, atmosphere. There is like literally, I think it's sulfuric acid or hydrochloric acid. I don't know, but I think there's like acid literally being the atmosphere, and the water itself doesn't exist. I believe. They have like liquid something which is not supposed to be liquid in our condition, which means that again it's due to the pressure or something that the gas actually starts to condensate. So yeah. um okay, that is unfortunate. Several other planets such as Gliese also appear to be examples of planets once considered potentially habitable but later found to be interior to the habitable zone, again too close. Similarly, Toshati or Toshiti, Toshati, I guess, were and F. Oh wait, what? Oh, E and F were initially both considered potentially habitable, but with improved models, does not consider either planet potentially habitable. But why though? I don't know. Was also initially considered potentially, but subject of powerful flares that can strip a planet of its atmosphere, so it's now considered non-habitable. Okay, so it's under, like again, extreme condition. There's it got it's close to flare, and it might happen, and if that actually happens, it will strip the atmosphere. So yeah, which is bad, right? Originally considered potentially habitable, and the latter remains okay, but recent studies shown them to be gaseous sub-Neptunes and thus unlikely to be habitable. Okay, so it's a gas planet apparently. Okay, it's like semi or um, semi. What is it like gas, but also solid because Neptune is not entirely gas. You already covered about that, I think. Oh wait, did I? Oh no, that'll be for the future. Okay, well there we go. A bit of spoiler. In the future, we'll actually talk about the solar system, and yeah, one of them being Neptune, and apparently it's not as gaseous as I thought it's supposed to be. But yeah, considered potentially habitable as well, exoplanet after its detection in 2011, until proven false. Okay, several other KOIs were considered potentially habitable, but with new data are no longer considered habitable. I guess it's just the same, right? It's either the location is a little bit too close, or maybe there is something else like extreme condition, like maybe there's flares over there. I don't know, but yeah. But anyway, that is all of the thing, unfortunately. And yeah, we kind of already tell, right? There's this amount, but none of this is actually, it might potentially be habitable, but it doesn't necessarily that something lives there, right? So maybe they already checked again by telescope. I don't even know if that's possible or not. Like literally, you see the planet like closely and see, like literally you can see if there's anything changed or not. But also keep in mind that this is far away. There might have been, like what is it like because space, there's like planets masses and stuff like that. This bends the space and time, which means that what you see is over there, like in front of you. It might not necessarily be in front of you, it might actually be somewhere else, maybe slightly to the right, maybe slightly to the left, because the light got what is it like refracted or distorted because the space time of the universe is not like homogeneous, right? So yeah, maybe that is also a factor. I don't know if that makes any big thing or not. So yeah, but anyway, that is it for now. Again, like we can just see from this list that again, if you just think about, oh yeah, there's another life form, universe is too wide. Well, I have something else to tell you that, don't forget about time as well. Out of billions of years, what makes you think that, the life doesn't choose other time in timeline, right? Why? What makes you think that actually something also happens in this exact same time, like another intelligent life form just like human, which I think it's most likely not happening like right now, because again, all these planets doesn't show anything. Well, I mean, it's not mentioned over here, but I guess it technically you can say it doesn't show anything. I mean, if it shows anything, it will probably get recorded over here. So yeah, um again, like maybe again, maybe it already happened, maybe doomsday happened to them, in the past, just like dinosaur. Maybe there is a meteor, that is like universal problem, right? Like meteor crash, yeah, like that might happen. And what else, like maybe it happens not yet, maybe it happens in the future, maybe like right now they are still in the step of evolution, maybe they still need few million years until they fully develop, who knows, right? And by the time they fully develop, we might have gone already, or maybe we evolve to something else, or again, simply maybe doomsday already happens to us, but who knows, right? But yeah, anyway, I think that for this one, I hope you guys enjoy it. Stay so healthy. I will see you again tomorrow with another discussion. maybe for the next space discussion, I will talk about black hole. Maybe I have no idea. Like if it's actually possible or not for planets to, instead of circling around the sun, it circles around a black hole. Like, is that a thing or not? So yeah. But anyway, until then, see ya.